So let's see once again. If I try to find this integral using technique that we see in the last lecture, if I try the u substitution, if I let my u be x squared minus x, which is the denominator here, my du is gonna be 2x minus 1 dx. And I don't see anything like 2x plus 1 anywhere else in the integral. Or if I try to use integration by part, I like to write the integral as the integral of u dv. And once again, I don't see any thing that I can use as u and v easily in this integral. So I can try the integration by partial fractions here. The integration by partial fractions, the idea is that, so let me kind of write on the side here, partial fractions. Partial fractions. So the integration by partial fractions is going to be useful when the thing that I have to integrate, that I would like to integrate, looks like I have a polynomial over a polynomial. In other words, I have a fraction of a polynomial where the denominator here can be factored. So I can factor this bottom part. I can be factored. So the methods for the integration by part is that the first thing that I would like to do is to, well, basically I said that the denominator can be factored, so I'm just going to factor the denominator. In this case, we can see that x squared minus x is going to be just x times x minus 1. So I have factored the two things. Now once I do that, I'm gonna rewrite the thing that I would like to integrate, that big the big fractions here, as a sum of two smaller fractions. So it's gonna be a over something plus b over something, where this something is the factor that we have found earlier. In other words, I would like to write the functions that we see in the integral, which is 1 over x squared minus x, as a sum of two quotient of two of two fractions instead, where the denominator is going to be just the two factors that we have found earlier. So one of them is going to be x and the other one is going to be x minus 1. But I don't know the numerator yet, so I'm just going to write that as a and b for the moment. So for the next step, I'm going to have to solve for a and b. To solve for a and b, I'm going to have to add up the right hand side that we see here. If I add these two things up, that's going to give me, let's see, if I add these two things, I'm going to multiply x to the x minus 1. So that's going to be just x squared minus x. So the denominator will always come out right, because that we kind of factored them earlier. If I multiply x minus 1 to a, so that's going to be ax minus a, and then I multiply x to b, so that's going to be plus bx. I can now collect the term with x, so that's going to be ax plus bx, so that's going to be a plus b times x, and then minus a. This whole thing over x squared minus x. Now to solve for a and b, what we would like to do is that we will compare the coefficient by comparing the coefficient. Notice how so these two things have to equal, right? But on the left hand side, I have just 1, so this one is just 0x plus 1. So my left hand side, I have 0x plus 1. But on my right hand side, I have a plus bx minus a. So the coefficient has to equal. In other words, this 0 here has to equal to a plus b. And this 1 here has to equal to negative a. So now I have two equations that I can solve. So my 0 has to equal to a plus b. This is the yellow equation. And I have that 1 has to equal to negative a. So this is the blue equation. So that means my a is negative 1 and my b is 1. I can plug that back in. So that means what we have earlier, my a is gonna be, let me see, I have to write somewhere. So let me move this thing further away. So that means what we have found now is that 1 over x squared minus x that we have earlier, we said that it is equal to a over x plus b over x minus 1. And we have solved for a and b. My a is going to be just negative 1 and my b is going to be just 1. So my a is negative 1 and my b is just 1. So that means the integral of x squared 1 over x squared minus x here is just going to be the integral of the right hand side that we see earlier. So I'm going to have that the integral of 1 over x squared minus x dx is just going to be the integral of negative 1 over x dx plus the integral of 1 over x minus 1 dx. And now I can do these two integration. The integral of negative 1 over x, I can pull the negative out, and the integral of 1 over x is just going to be log of absolute value of x. For the latter half, the integral of 1 over x minus 1, I can do the u substitution. So I'm going to let my u be x minus 1. Let me kind of write that up here. If I want to integrate 1 over x minus 1 dx, so I'm going to let my u be the denominator here. So my u is x minus 1. And my du is just going to be dx. So this integral now become 1 over u du. So that's just going to be log of absolute value of u, which is x minus 1 plus c. So then I can write this latter term as just log of absolute value of x minus 1 and then this whole thing plus a constant c. So I can write this as the fourth step then basically. So once I write this big guy as the sum of two smaller guys, I can go ahead and integrate these two things. So in the end, I'm just going to have to integrate the two terms that we have earlier. So now let me try to do the part B here. I would like to integrate 3 over x squared plus x minus 2. So I'm just going to do the step here. I'm going to have to factor the denominator. So now my x squared minus x plus 2, that I can factor this as x plus 2 times x minus 1. Wait a minute. I flipped the sign here, so let me kind of rewrite. This should be x squared plus x minus 2, and this is going to be x plus 2 and x minus 1. Okay. So then I'm going to want to try to write the terms of this integral, which is 3 over x squared plus x minus 2, as something over x plus 2 plus something over x minus 1. And I'm going to have to try to solve for a and b here. To solve for a and b, I'm going to have to add the right hand side together. So this is going to give me the the denominator. Well, that's just going to be x squared minus plus x minus 2. I multiply x minus 1 to a, so that's going to be ax minus a. I multiply x plus 2 to b, so that's going to be bx and then plus 2b. I collect the x term, so that's going to be a plus b times x. And the other term is going to be negative a plus 2b. So let me write negative a plus 2b over x squared plus x minus 2. Now then, I can compare the coefficient. This 3 that we see here is just 0x plus 3. So the coefficient for x and the constant term that we see here have to be equal. In other words, this 0 here has to equal to a plus b. So that's going to be my first equation. Let me write here. 0 has to equal to a plus b. That is my yellow equation. And then the constant term has to be equal as well. This 3 here has to equal negative a plus 2b. So my 3 has to equal negative a plus 2b. This is going to be my blue equation. I can add these two equations together, and that will cancel out the a. So I'm gonna have that 3b equal to 3. So my b is gonna equal to 1, and that make my a equal to negative 1. In other words, this thing that I have here, this is the same as a is negative 1, so that's gonna be negative 1 over x plus 2, and then plus 1 over x plus minus 1. So now I can write the thing in this integral as negative 1 over x plus 2 plus 1 over x minus 1. So then this thing, let me use another color here. So then this thing, let me kind of move over here. So this thing is going to equal to the integral of negative 1 over x plus 2 dx plus the integral of 1 over x minus 1 dx. Now I can integrate these two things using u substitution. So in the first case, I'm just gonna let u equal to x plus 2. So I'm gonna just write out the answer here. My u is gonna be x plus 2. So my du is gonna be just dx, and then the negative sign will just stay there. So this is gonna be the negative of. This is going to be just the negative of log of absolute value of u, which is x plus 2, plus the integral of the second term. Well, once again, I can let u equal to x minus 1, and du will just be dx. So the integral in the second term is going to be just log of the absolute value of u, which is x minus 1. And then the whole thing plus c. So here is my answer for part B. So basically here is how we do the integration by partial fractions. Once again, it's going to be useful when there are the functions that we try to integrate are the fractions of polynomial. If I can write this big guy as a sum of two things, then I can integrate these two things using the u substitution, as we can see here.